I'm going to present our paper called V1SCAN, which is a precise approach for discovering one-day vulnerabilities in the third-party open source software components. So I'm the presenter Seunghoon, and Eunjin Choi, Professor Heejo, and Professor Hakjoo also work together. Okay, so the reuse of open source software has become an essential in recent software development. But however, unmanaged OSS reuse can cause several security threats, such as the propagation of vulnerabilities. So consider the following situation. The target program is reusing a third-party open source component, which contains many other sub-components in their code base. So in this situation, to prevent threats from the propagation of vulnerabilities, first, we should identify whether a vulnerable third-party OSS component is contained in the target program code base. This also applies to all the sub-components. And next, we need to examine whether the vulnerabilities of third-party components were actually propagated to the target program. So to achieve these goals, two major approaches have been conducted, namely called version-based and code-based approaches. The version-based approach detects vulnerabilities based on the version information of the reused third-party components. And the code-based approach tries to identify the codes that are syntactically or semantically similar to the known vulnerable code. However, in practice, developers reuse OSS with code or structure modifications. So because of this modified OSS reuse, existing approaches produce many false positives or false negatives. So existing version-based approach produce many false positives because they focuses only on the version information and do not fully consider the code changes that occur during the OSS reuse. So they cannot effectively address the unused or resolved vulnerabilities. For example, when you apply a version-based approach to the ReactOS program, this approach can detect the vulnerable WebTI RPC version with 3 known vulnerabilities. However, the ReactOS team resolved these vulnerabilities by backporting security patches. So in this case, the 3 vulnerabilities can be determined as false positives. And next, existing code-based approaches produce many false negatives because they cannot effectively address the vulnerabilities in modified code. So they misses some modified and propagated vulnerable code. So to overcome such problems, we present V1SCAN. V1SCAN is a new way to combine the improved version and code-based approaches. So the key technique used in V1SCAN is called code classification. So to eliminate false positives of existing version-based approach, V1SCAN uses reused code classification and also leverages the improved code-based approach. And to complement the first negatives of existing code-based approaches, V1SCAN uses vulnerable code classification and also leverages the improved version-based approach. So now I will introduce the key techniques used in V1SCAN. After identifying, to address false positives in the existing version-based approaches, V1SCAN uses the reused code classification technique. So after identifying the third-party components in the target program, we examine the original OSS code base for our components, and then classify the functions contained in each code base into the following 3 categories: exactly reused, modified, and unused functions. So among the 3 groups, only the exactly reused and modified functions are contained in the target program. So we perform this reused code classification based on the fuzzy hash techniques, and the detailed method is introduced in our paper. So after classifying all the reused functions for our component, V1SCAN then detect the candidate vulnerabilities for each component by using the CPE information of the embedding. But as I previously mentioned, these candidate vulnerabilities may contain some false positives, which are unused or resolved vulnerabilities. So to filter out such false positives, we devise a new filtering method. So let the func be a vulnerable function of a detected vulnerability. So if this func is contained in the exactly reused functions, it means that this vulnerable code is exactly propagated to the target program. So V1SCAN determines that this result is a true vulnerability and does not apply any filtering method. If the func is contained in the unused functions, it means that this vulnerable code was not propagated to the target program, so V1SCAN filters out this vulnerability from the result. Last, if the func is contained in the modified functions, maybe the code modifications contain the security patch. So in this case, V1SCAN compares this func to the original vulnerable and patched functions of the vulnerability. So if the syntax of the func is more similar with the patched function than the vulnerable function, V1SCAN determines that this vulnerability was resolved by backporting security patches and thus filters out this func from the result. So by applying the reused code classification and also devising a new filtering method, V1SCAN can address the false positive problems of the existing version-based approach. And next, to address the false negatives of the existing code-based approaches, V1SCAN uses the vulnerable code classification technique. So we classify the code locations where vulnerabilities exist into the following 4 groups: function, structure, macro, and global variables. So, then V1SCAN takes an effective vulnerability detection approach for each code location. So the left code snippet shows an example security patch, which contains all the 4 code locations we defined. For each code location, V1SCAN generates a signature by considering the code lines added and deleted in the security patches. So to detect the syntax modified vulnerable code, we only focused on the code lines added and deleted in the security patches. So in the cases of macros and global variables, if all the deleted code lines are contained in the target program code base, while any added code lines are not contained in the target program, V1SCAN determines that this one-day vulnerability exists in the target program. However, in the cases of functions and structures, if we use the same method, false positives can be produced, especially when the deleted code lines are very short or general, such as the return statement. So here we consider one more condition. So V1SCAN first verifies whether a function similar to the vulnerable function exists in the target program. So if the similar function or similar structure is detected in the target program, then V1SCAN verifies whether the deleted code lines are contained in the similar function. So this allows us to avoid producing false positives, which exhibit a completely different syntax but contain the short and general deleted code lines. So by using the vulnerable code classification technique and also by considering only the added and deleted code lines, V1SCAN can address the first negatives of existing code-based approaches effectively. So by consolidating the result of the improved version and code-based approaches, V1SCAN can provide the one-day vulnerabilities exist in the target program. So to evaluate the V1SCAN, we constructed 3 types of data sets: CV dataset, CP dataset, and the target software dataset. So we collected more than 4,000 C and C++ security patches from MVD. And we extract the 4 vulnerable code locations and also generate the signatures. And we also collected CPEs from all CVEs. This dataset is used for discovering the candidates' vulnerabilities in improved version-based approach. And last, we selected 10 target software programs, which are popular and contain many OSS components in their code base. So when we apply the V1SCAN and 2 state-of-the-art existing one-day vulnerability discovery approaches to the selected 10 target programs, we confirm that V1SCAN outperformed existing approaches by discovering 50% more one-day vulnerabilities than the state-of-the-art approaches. So V1SCAN could detect 137 true positives, true vulnerabilities, whereas the existing approaches detect at most 90 vulnerabilities with many false positives. Next, we compare the V1SCAN with existing version-based and code-based approaches as the baselines. So we observed that V1SCAN could reduce the first positive ratio of the version-based approach from 77% to less than 4%. And also it can reduce the first negative ratio of existing code-based approaches from 49% to less than 9%. So these experiment results demonstrate that V1SCAN can be used as an effective one-day vulnerability discovery tool in practice. Okay, so this is the conclusion. One-day vulnerabilities have various propagation patterns. For example, it can propagate with code modifications, or it can be resolved after propagation. So to effectively discover such one-day vulnerabilities in third-party components, we present V1SCAN. And the V1SCAN can outperform existing approaches. So with the help of V1SCAN, developers can address the potential threats caused by the propagate vulnerabilities in third-party components. So this is the end of my presentation. Thank you for your attention, and if you have any questions, please feel free to ask. Thank you.